Another popular statistic is the correlation matrix. The correlation matrix is easily made by using the core function of the data frame. So, but if we do this, we see that, well, we get an error and we could not convert a string into a value. This means that we have to go back to our initial data analysis and see which values or which columns are indeed not numbers. And we have to drop these. So we can do that with the .drop function. And here we have to specify the columns, and we specify city. Okay. So now we have dropped the city column, as we see here. We only have numbers or numerical variables. So now we can use the core function on this result. And if we run this, we see that we get the correlation matrix with price against price is obviously 1 because they are the same variable. But here we are interested in, for example, modeling price. Then we would hope for the correlations on some of these other variables to be either positive or negative and not around 0, for example, as some of these are. So what can we do about this? It's not very readable, so we could actually round this result. And we remember that we can just provide the data, which is to be rounded, and the number of decimals. Then we run this. And now the correlation matrix is a lot more readable. The use of this now is for us to look at the price, obviously, which we want to model, and these correlations of these variables with price. And for example, square meters has a positive correlation with price of 0.38. So that might be an input to the regression model we are going to make later on. Maybe first floor and balcony or terrace, parking, definitely Oslo because it has a high positive correlation. But also the variables that you include in the model should not be correlated with each other. So for example, if you add square meters and Oslo as inputs to your model, like X variables in your regression, then you want those to not be very correlated with each other. So you see here that square meters and Oslo is correlated at negative 0.2, which is not very high, so that should not be a problem. What we can do also is to investigate or make a correlation matrix on a subset. So now we have data, and we would like to only look at price and square meters and, for example, bedrooms. And now we can use the correlation matrix on that. So now you get a smaller correlation matrix, which is easier to navigate. And of course, we could just run this one as well. For example, 2 decimals, usually enough. And here you have it. It's quite nice to read.